Hello, this is Dr. Jim Schaefer, and we're starting today the course on chemistry in agriculture. Chemistry in agriculture is a big topic. A lot of agriculture is defined by chemistry, principles of chemistry, the formulas of chemistry. That includes crops, livestock, whether we're dealing with the production of food, feed, or fiber in agriculture. Chemistry is a central defining science that defines agriculture. Many of us who've studied agriculture all our life, sometimes we get a little rusty and we don't remember all of the basic principles of chemistry and how they might be applied in agriculture, and how we are actually managing those principles in the management of various types of agriculture. So this course will attempt to bring out some of these fundamental areas of science of chemistry, and then also demonstrate how in agriculture we manage those elements of chemistry in our day-by-day practice. So for this first course, I'm going to give a basic introduction and share my screen now. Okay, chemistry in agriculture. A little bit about myself. I'm an agronomist and soil scientist. I also own farms and have been involved in agriculture all of my life. I grew up on a farm in the state of Illinois, grain and livestock operation. Obviously, my father was a farmer. My grandparents were farmers. My great-grandparents were farmers. I am educated in agriculture to PhD level, agronomy specifically. And I do a certain amount of lecturing at universities and have done lecturing all over the world, especially in the area of organic agriculture. Universities, at government offices, and industrial meetings. I'm a founder of a agricultural biotechnology company that's been in business for 39 years, Soil Technologies Corporation, which is the sponsoring this course for everyone. My family, my father on the left, my brother, my nephew, we were and continue to be a family farm, or a family with an agricultural background. What is chemistry? Chemistry is the study of the structure, function, and properties of matter and the changes it undergoes. Chemistry is the study of the composition of matter and the changes that matter undergoes. Since living and non-living things are made of matter, chemistry affects all aspects of life and most natural events. Chemistry can explain why some foods taste sweet and some taste bitter. It can even explain why there are different shampoos for dry or oily hair. Chemical changes that occur in leaves can cause brilliant displays of color. And then we have chemical interactions. Chemistry is the study of elements that make up the material universe and the interactions between these elements. Chemical interactions and molecules. So we looked at the elements on the periodic table. It includes things like hydrogen, oxygen, and when these two elements are combined, we have a very familiar molecule, which is called H2O. So we have elements and we have molecules in the basic structure of chemistry. Chemical interactions in agriculture can include many things, especially in plant physiology. It includes germination chemistry, plant cell elongation chemistries, photosynthesis chemistry, plant energy transfers. This is the metabolic system of the plant, the nutrient uptake. These are the osmotic forces that move nutrient materials across the membrane of a root. Pollination, the reproductive processes and the biology of reproduction involves chemistry. Seed and fruit formation on a plant involves chemistry. Chemistry as a science. Here you have a cone, and it's divided into two sections here in the middle. This is the regions of linear behavior. These are things that we understand about chemistry. But chemistry is a science that's continuously expanding its base of knowledge. And we were estimating here in this cone as much as half of what might be known in chemistry is still unexplored and unexplained. So over time, we may be adding elements to the periodic table as we discover new elements, as we understand the interactions in the animate and inanimate world. These chemical interactions help us understand more about chemistry. So the process of discovery, the process of exploration is ongoing. So the science of chemistry is a moving target. It is a body of knowledge that is evolving and is likely to change. And what chemistry looks like today as a body of knowledge, it's probably going to look different 10, 20, 30 years from now. This course is sponsored by Soil Technologies Corp. in association with Maharishi International University in the United States and its Department of Regenerative Agriculture. Also in the UK, this course is hosted by Global Education Development Limited, and in the Netherlands, Global Country of World Peace, an NGO. So I'm going to stop my screen share for this PowerPoint and switch to a new PowerPoint. Properties of matter and states of matter. There are three states of matter: solids, liquids, and gases. Matter defined: it is the stuff of the universe. A substance is a type of matter that has a defined fixed composition. Properties: the characteristics that give each substance its unique identity. There are physical properties and chemical properties to matter. Physical properties: solids, liquids, and gases. Characteristics of a substance that shows by itself without changing into or interacting with another substance. A physical change occurs when a substance alters its physical properties, not its composition. Ice to water, water to vapor, which is a gas. The actual substance did not change. It's still the molecule H2O. Chemical properties: characteristics of a substance that shows as it changes into another or interacts with another substance. A chemical change or chemical reaction occurs when a substance is converted into a different substance. This is a chemical reaction. The actual composition, the molecular form, actually changes. States of matter: solids. A solid has a fixed shape that does not conform to the container shape. Particles in a solid lie next to each other in a regular array, like a crystal or ice crystals. The molecules are arrayed in a very regular array. Liquids have a varying shape that does conform to the container shape, but has an upper surface. Particles in a liquid also lie close together, but are more randomly placed around each other. Whereas a gas also has a varying shape that does not conform to the container shape, but does have a surface. Particles have greater distance between them and move randomly throughout a container. Temperature and states of matter. Temperature can cause matter to change its state. A physical change caused by heating can generally be reversed by cooling. Chemical changes cannot be reversed with heating and cooling. Very important distinction there. For example, with increasing temperature, ice will melt to a liquid, and with further heating, water will become a water vapor. This can be reversed by decreasing the temperature. The central theme of chemistry. On a macroscopic scale, properties and behavior, those we can see, are the results of atomic scale properties and behavior that we cannot see. Macroscopic properties of a substance in any of the three states arise from atomic scale behavior of those particles. Here you have the macro scale, the micro scale, the nanoscale, and finally the atomic scale, where you have quantum molecular structures and you have quantum field changes. The behavior of the atoms can change. Nature's intelligence. The range of intelligence in nature is from the smallest of the small to the largest of the large. The structure of chemistries, the structure of molecules, the behavior of atoms at the atomic level reflect some organization and intelligence in nature. And this occurs from the atomic all the way to the macro scales. Here we have a video clip. I'm going to skip the video clip for now, but I will go back to it so you can see it, and you can mark it down if you would like to watch it, but I have not embedded it in the video here. It's just a reference clip about chemistry. Agricultural examples of how gases and solids and liquids are managed in agricultural systems. The study of soil. The study of a soil environment is a study of water, air, minerals, or the solid phase, as well as organic materials, which could be considered semi-solids. So we have a gas phase, a water phase, and a solid phase to a soil. In the air phase of a soil, roots absorb oxygen from the air that's present between soil particles. This absorption takes place through the root hairs, air spaces, soil particles, ground, and it's often the case that people forget in agriculture that plants take up oxygen through their root systems. And in this case, they access that oxygen in that fraction of a soil profile that should be air. If the soil does not have good airspace, the plants may be deprived of oxygen and become oxygen deficient. Oxygen is a very fundamental molecule or element that is instrumental and helps fuel the metabolic process in the plant. water. In agriculture in the United States, we have what are called buffalo wattles. They're in fields that you find all over the middle of the United States. And there are areas in the old original prairies where the buffalo would go and basically destroy all of the grass with their hooves, all the way down to the dirt or the dust. And the buffalo would lay in these dusty, round, normally they were round areas or sort of round. They would lay in these dust bowls in order to get dust on their skin, which formed a type of protection against insects that might bite them and damage them. Here you can see a buffalo in action in modern times. They wallow on the ground in order to get dust on their body, and that dust is protection of their skin. But these buffalo wallows, here's an example of one from 100 years ago or more that was photographed, almost perfectly round. And these actually become wet areas in modern farm fields. They've been dug out. The buffaloes have thrown the dust out of the bowl so they can access the dirt and the dust below. And they've left these, what we call buffalo wallows, in the middle of the field. Managing those wet spots in a field is something that a farmer does and we would call that managing the liquid phase of water that might accumulate in these bowls as wet spots in a field. Here's an example of a wet spot in the field. This is a prairie grass field, and perhaps in the state of Kansas in the United States. And this is an example of an old buffalo wattle in that field. And if you can imagine, if this was a cornfield, you would have to do something about that to drain it. Otherwise, the corn would not grow there because it would be too wet. It tends to stay too wet. Here's what these kind of wet spaces look like in a cornfield. And you can see that the wet areas of this cornfield are not allowing the corn to grow. It is a process of almost drowning the corn or making the corn, because the soils are waterlogged, there's no air in the soil, all of the pore space is filled with water, there's no oxygen available to the root system, the plants do not survive. Managing water in fields is a big part of agricultural management, either through drainage of excess water or the supply of water when water is short in the field. This is an example of a drainage field, and because the ditch is dug at a very deep level, the waters from the field drain off through the substrate of the soil into the ditch, allowing the fields to have more airspace in the porosity. And as you can see, the crop performs very well. If this water was allowed to simply accumulate at the surface of this soil, they may become waterlogged, they may become oxygen deficient, and the crops may not perform well. So this is a form of managing water in an agricultural field management situation. Okay, this is irrigation. So here they're irrigating fields in ditch line irrigation. This is sort of like flood irrigation, but in the ditch line, in the row line, and the water is moved from one end of the field to the other by gravity. So this is a case where the field has a shortage of water, irrigation water is delivered in order to maintain that fraction of the soil environment that should be the water fraction. The deserts of the Sahara and many other deserts around the world are using water from aquifers. They pump it to the surface and they use it center pivot. In this case, it's center pivot irrigation. There are many types of irrigation. Subsurface irrigation is the most efficient form of managing water in agriculture. It delivers the water below the surface directly next to the root zone. That way you have minimal evaporation of your irrigation water. This type of agriculture where you're delivering it in a center pivot, it would be considered the least efficient, where you have the maximum amount of evaporation of your irrigation water. But managing water through various types of irrigation systems is an important part of managing water, a molecule, a form of chemistry that is essential to the growth of plants and animals. Here's another way of watering, very efficient. They're using ceramic pots. They fill the ceramic pots with water. The water leaks through the ceramic pot into the root zone, and you irrigate the plant where it needs to be irrigated, right next to the root zone of the plant. Drip irrigation system, another way of delivering in a very efficient way this chemistry that we call water. A semi-solid manure being knifed into a field. This is a way of managing a solid and getting it into the ground. Another solid, compost materials being delivered into a field in order to create a horticultural bed. Minerals in foods, these are solid phase of soils. And there are many different forms of minerals, both macro, essential minerals, and micronutrient-based minerals in a soil profile, which are all ultimately important components, mineral components of the food, feed, or fiber that we produce in agriculture. Fertilizers are basically these solid phased components that are either naturally occurring in the soil or that we add to the soil. This is a phosphate source. These rocks are very high in phosphates, which ultimately are mined and become fertilizer. This is a picture in Morocco where they have deposits of rock phosphates, and they mine those, process them to produce various forms of fertilizer that is used in agriculture. This is managing the solid phase in chemistry. Another solid phase, azomite. This is volcanic rock dust used in organic agriculture. And this solid material provides about 80 different mineral sources that are used to remineralize an agricultural soil. This is the distribution of, could be lime, it could be azomite, it could be various forms of minerals or solid materials that are being added to an agricultural field. We also obtain important elements from the air. These are gases. Obviously, our atmosphere around our planet is a form of gases. And the most common element in our atmosphere is nitrogen as a gas, N2. Nitrogen in the air becomes a part of a biological system called nitrogen fixation. It is executed by bacteria, rhizobia bacteria, on a legume, in this case a legume. And these rhizobia have enzymes that they produce that are capable of taking nitrogen as a gas and reducing that nitrogen to a liquid form of ammonia. Ammonia can be absorbed by the plant, which becomes a nitrogen source. Ammonia is a nitrogen source. The nitrogen is an element that is used by the plant metabolically to produce proteins. It's an important part of the chemical structure of a protein, specifically an amino acid. Okay? So this is called nitrogen fixation. The source of the nitrogen is a gas. It is in our atmosphere, and it's the most prevalent element in our atmosphere. And in agriculture today, we need to do more to maximize and optimize the sourcing of this nitrogen element, important in plant growth, whether it be a legume or a grass. But getting that nitrogen into the plant through nitrogen fixation, making it transferring it from a gas to a liquid ammonia chemistry available to the plant. This activity is the cheapest way to deliver nitrogen to any plant, whether a grass or a legume. We need to maximize that for the sake of agricultural economics in all forms of agronomy. We also manage air around animals. This is a livestock confinement environment, obviously for swine. And you see these fans here. They are designed, these animals in this kind of setting produce a lot of gases. Gases come from anaerobic, but especially anaerobic digestion of the waste from the animal. So these are bacteria, especially, that are breaking down the waste from the animal, producing a lot of gases into the environment of this confinement operation. The farmer's obligation as the farm manager for livestock is to manage those gases, get those gases out of the atmosphere of the living organism, the swine, the pig here. And because those gases are detrimental to the health of the animal. So this is a system of agriculture where gases must be managed in order to protect the health of the animal. Chickens, same story. Ventilation is a big part of managing livestock because animals, just like us, off gas, and these gases will accumulate in the atmosphere of the animals. We have to remove those gases. So this is ventilation for moving gases out of the environment of an animal. The same for young, in this case, these are dairy cows, Holstein, and we're bringing fresh air into them to move their air, to turn their air, to bring fresh air in, because especially animals in confinement like this that are living in close together, they have a tendency to be more exposed to infectious pathologies. And one of the values of changing the air in this kind of an environment is it minimizes the chance for pathological organisms to accumulate in the environment of the animal and consequently minimize the inoculation of these pathological organisms in the biology of the animal itself. So this is disease control for these young animals. Agricultural management requires management of gases, liquids, and solids. We need to understand agricultural management from the point of view of chemistry. That includes understanding agricultural management from the point of view of these chemical states of matter, gases, liquids, and solids. The next lesson will be a lecture on both energy and measurement. Energy as relates to the chemistry in agriculture, measurement as it relates to measuring chemistry, whether it be the elements or whether it's the interactions that take place between the elements in agriculture, farm management. So energy and measurement will be the next lecture. Thank you very much. We'll see you in the next session. Thank you.